All right, want to see if you can go the other direction. So you can also go from a rational power into a radical. So again, if you had, let's say, 5x to the 2/3, you can rewrite this in radical form by performing just the same connections. The base stays the same, so it remains 5x. The power of 2 remains the power, and the denominator of your rational power is the index. And so this would be your radical form of that expression. So with sample problem 12, I want you to see, just really quickly, can you identify the radical forms for each of those, please? If we take this first example, we have our base of y, our power of 1, which can remain unwritten, index of 7, to get the radical form. And what about b? What would b's radical form be? What nth root? Square root of x cubed. Okay, so you can write it in this form. You could simplify it out as x square root of x as well. Either of these would be fine when it's just asking you to convert. You don't have to completely simplify. Although if you do, you wouldn't be wrong. Would you need absolute values around the x here if you simplify? Can x even be a negative? No. So you don't even need to worry about it. And what about c? What nth root are we looking at? Again, a square root of t to the minus 3. Well, what does that minus 3 wind up doing? Takes our whole fraction, that base of t, moves it to the denominator, changes the power to a positive. So this is what it would look like. Again, you could simplify this. We haven't talked about rationalizing the denominator. That'll be in this last chapter, or the last section of this chapter. And we'll talk about that, or start to get into that a little bit. So you can leave it just here written in this form. And then finally, b to the minus 1/2. The negative is going to take the b, this base, and put it where? In the denominator. And the power is 1. Change the sign to a positive. The index is 2, so it's the unwritten square root. And so you'd get this as your answer. All right, so all of this kind of leads to what you need to be able to do as far as simplifying and reducing. And that is, without using a calculator, you guys should be able to simplify numbers. So if I said something like 81 to the, say, 3/4 power. Okay. When you're looking to reduce these, okay, whether they're written as radicals or rational powers, what you need to do is, anytime you see your base that's a perfect power, think of it in terms of its exponential form. So 81 you should recognize as what? 9 squared. So if you take this and go 9 squared to the power of 3/4, okay, this will simplify what you have to do. So now, using properties of exponents, you have 9 squared to the 3/4 power. What do you do when you take a power to a power? You multiply. So 2 times 3/4, the 2 and the 4 cancel, leaving 9 to the 3/2, correct? Okay, now, is 9 written in its simplest exponential form? You can also write that as a power, right, in exponential form. What else can you represent 9 as? So if you think of it as 3 squared to the 3/2 power, again, you take a power to a power. The 2 and the denominator of 2 cancel. You're left with 3 cubed. And what does 3 cubed equal? 27. And so that would be your answer. Okay, so anytime you see a perfect power, you want to represent it in terms of its exponential form, and just keep going down as far as you need. Now, it might be that you don't need to go all the way down, and it might be that you do, especially for numbers like 81 and 64 that are powers of different bases. Okay? So be aware of that and just kind of break it down piece by piece.
Can you do that blue part again?
This one here?
Yeah.
Okay, so from this step right here, you could also think of, again, you can think of this different ways. If it's easier for you to work in radicals, you can convert at this stage. What does this power of 1/2 actually convert to in a radical form? If you were to convert this into a radical right here at this step, you would get the nth root, the index is 2, so square root of 9 cubed. And remember the rule for radicals, it doesn't matter whether you perform the power inside or the radical first, so you could think of this as the square root of 9 cubed. The square root of 9 is 3. 3 cubed is 27. So you could solve it this way. If you thought of it in this term, I'll redo that. Okay. And that is, if you thought of this base of 9 as 3 squared, and it's still taken to the power of 3/2, what you could then do is apply the rule power to a power. You multiply powers. So 3 squared times 3/2, you multiply these two powers. The 2 and the 2 cancel, leaving 3 cubed, which you could then identify as 27. I want you just to try those 2 sample problems on 13 really quickly as well, please. So if you're looking at this, 4 is a perfect power, so you can think of that as 2 squared to the 5/2. When you take a power to a power, you multiply the powers. 2 and the 5/2 cancel, factors of 2. So you get 2 to the 5th as your answer. And now again, on this one, I wouldn't specifically make you expand that out, but you can use the properties of exponents to do that. 2 to the 5th is the same as 2 squared times 2 cubed, correct? You add the powers. 2 plus 3 gives you 5. So if you break it up into pieces that are easy to manage with a mental calculation, what is 2 squared? And then 2 cubed. And 4 times 8 is 32. So again, if you were looking for that and 2 to the 5th power is not one of the answer choices, let's say on the final, you should be able to expand it out pretty easily mentally without having to wait for your calculator usage time. Okay. With B, it's the same idea. You have your base of 27, which you should recognize as a perfect power. It is 3 cubed to the negative 2/3 power. Take a power to a power. The factors of 3 cancel, and you get 3 to the minus 2. Well, 3 to the minus 2 is equivalent to taking your base of 3, moving it to the denominator, changing the sign of that power, and then 3 squared is 9. So 1/9 winds up being your simplified form.